Alright, hello everyone, Mr. Stevens here with another video on addition and subtraction of algebra. What we're going to be really talking about today is like terms. You will probably be more familiar with this topic by that name. So the things we're going to be focusing on are identifying sets of like terms by looking for the same pronumeral. That's going to be the key thing that we want to remember today. Like terms have the same pronumerals. And what we're going to do once we get really good at identifying these sets of like terms is we're going to combine sets of like terms into just one term to simplify our expressions. So because we're only just getting back into algebra now after the summer break, we're going to just do a quick little bit of revision. I want you guys to have a go at this question in your books. You can pause the video here, have a go, and then come back. Alright, so the terms, these are the individual terms, so there are obviously 4 in this expression. Now, the coefficient, when we're talking about the coefficient, we're talking about the thing in front, the number in front of the letter. So the coefficient of A and the coefficient of B is 5 and minus 4. Don't forget that this minus belongs with this term. And the constant term is the one that never changes. 7 is always going to be 7. It doesn't matter what we make A and B, 7 will always be 7. That's why we call it the constant term. Right, this is another one that I want you guys to pause and do on your own. I'll show you how to do the first one and then you can fill out the last 3. We want to use this line to divide 2 sets of like terms. So on the left side of the line, we're going to put everything that's a like term with 4x. So that means everything that has an x. And 8x will be the last one. Okay, so that's our set of like terms, all having an x. And then on the right side, we're going to put everything that has a y, because these are all like terms. And now I want you guys to just quickly fill in the next 3 sets. The 2 and 3 should be quite easy, but you might have to think a little bit about 4. Right, so there you go. Your solutions should have looked something like that. Right, moving on now. I'm going to do this one. I want you guys to just watch this. Don't worry about copying down this example. Once we have a pair of like terms in an expression like this, we can actually write this as one single term by simply adding together the numbers out the front. In this case, we have 11 A's. If you'd like, you can think of it this way. On this side, we have 4 A's. On this side, we have 7 A's. What's the total number of A's we have? If we count them all up, we have 11 A's. Again, over here in this second one, we identify our like terms. Sorry, I wrote that wrong. We identify our like terms. We've got one here and one here. So now all we have to do is put together the numbers out the front. If you like, you can think of it like this. And then there's no like term for 4, so it just has to stay how it is. So we're going to end up with x plus 4. If it helps you to think about it by writing it like this in brackets, you could have done it over here as well. 4 plus 7. Sorry. 4 plus 7a. While you're just getting the hang of it, if it helps you to write it out like that, I'm happy for you to go ahead and do that. Alright, I want you guys to pause right here and have a go at this one. This one should be pretty straightforward. In this one, we've got two x terms and two y terms. We've got 3x and 4x, so that combines to give us 7x. We've got 2y and 7y, so in total we have 9y. So in this one now we have 3xy and 1xy, so in total we have 4xy. And we have plus 4x minus 6x. So plus 4 minus 6 is actually minus 2x is left over. Now we have to be a little bit careful here in this last one. Let's deal with this ab squared first. We have an 8ab squared and we have a minus 5ab squared, so 8 and minus 5 is going to be 3ab squared. Now if we look at these two terms, we have 9ab and we have 3ba, minus 9ab, sorry. Are those like terms? Well, the answer is actually yes. If you think about it, when we multiply two things together, the order does not matter. So when we look at these two terms, minus 9ab and 3ba, what that really means is minus 9 times a times b, or 3 times b times a. So it doesn't really matter what order these letters come in, they mean the same thing. We could just as easily write this as minus 9ba, or we could write this as 3ab. It doesn't matter, those are considered like terms. We can combine them. Minus 9 plus 3 leaves us with minus 6. I'm going to write it as AB. So we're going to just check in here. What we should be able to do now by the end of this lesson is we should be really good at identifying sets of like terms and combining our sets of like terms into one single term by simply adding or subtracting the number out in front of our like terms. So what you guys are going to do now to just practice that and solidify it is you're going to go to chapter 3 of the textbook, page 100, and you're going to have a few questions here to do. Thanks, guys.